So here we have to find those values of the theta that fall between 0 and 2 pi that satisfy this condition. So one simple way would be to just use the calculator. Pi over 4 is 45 degrees. So you could either do it in radian or degrees. Tangent 45, as you'll find, is 1. So that eliminates A and E. And then 3 pi over 4 is 135 degrees. That is indeed minus 1. So these two are in consideration. That one is out. And then we just find 7 pi over 4, which would be 7 times 45. And that would be 315. And the tangent of that is minus 1 indeed. So we know that the answer is C. So that's one way. The other way is to use the unit circle approach. So if we look at this unit circle, the way I like to think about this is that if we know that tangent 45 is a 1, so here if x and y are 1, this would be 45 degrees, but we're looking for minus 1, and that means that in the ratio, if you go on in the second quadrant here, this x would be negative. So if we pick the point minus 1 and 1, or they're equal, then in that case the tangent, which would be the ratio of these two, would be minus 1. And in that case, we're looking, this would be 45, so that angle would be 180 minus 45, which is 135. So that would be 1. If you go to the third quadrant, here both of them are negative, so that's going to give us a positive ratio. So we have to come back here, and again 45 here, so we have this measure, which would be 2 pi minus pi over 4. So I'm kind of switching because 45 degrees is pi over 4. So that is 7 pi over 4. And that would also be negative 1, because here the x-coordinate is positive, y is negative. So we know that both 3 pi over 4, which is 135, and 7 pi over 4 also are the only ones that satisfy this condition that tangent theta is minus 1. So it's kind of good to know this approach about unit circle, but going back to, you can always just do this directly using the calculator. This problem is easy enough for that. So to recap, the answer is C.